Let's try this again. Okay, back to recording. So we're trying to rotate this 90 degrees in a counterclockwise motion. So we're moving from here to here. Let's look at my new points. B prime is at -1, -4. -1, -4. X prime is now at 2, -3. Oops, I want to do M prime first. Sorry. Go in the order I wrote them in. So M prime is at 4, -5. And then X prime is at 2, -3. Anybody notice any sort of pattern here with these points compared to their original? Go ahead. Okay, they flip. So where X and Y flip, anything else you notice? What about the signs? Okay, they all ended up staying negative on the right side. So all my X's were negative to begin with, then all my Y's stay negative. That's a good observation. Sorry about that. There you go. What happened to the left side though? I went from 1 to -1, -4 to +4, -2 to +2. Yeah, all the signs there change. So our rule will be -y, X. In other words, we flip X and Y, then change the sign of the front number. So we flip places with X and Y, then we're going to change the sign on whatever's in front. So here's the nice part about these. These rules always say the same. So if I'm doing a 90-degree rotation in example 2, I know it's going to be, again, -y, X. So let's flip this, and then the number that ends up in front, we change the sign on. So what should the new point for Y be? Well,
This should be. Oh my God. I got negative, that's gonna be a -4. Wait, that's gonna be a 4 and a -3.
yes, but we need to just switch that order around. Yeah, so -3. And 4. Yeah. We need to switch the order and then change that sign. So then the next one would be -3, 5. Next one, -0. Well, we really don't have to write a negative from 0, so that's 0, 5.
And that's +2, -2.
+2, actually.
Oh, that's not what the negative is?
Because remember when we
That turns
flip,
positive.
the -2 now goes in front, positive in the
Okay.
back.
Oh, so that.
So
Okay.
the negative in front changes to a positive, the positive in the back stays positive.
Okay.
So now let's plot these points and see if it really does look like we took this and spun it 90 degrees. So -3, 3, 4 will be up here. -3, 5 is up here. That is Y prime, K prime. B prime is 0, 5. That's up here. And I have B prime, Then I have u prime is 2, comma 2. I play connect the dots on this. I now see this shape spun around up here. Does that make sense on how a 90-degree rotation can work?
I'm gonna say it's not common sense.
So we need to make sure you have these rules written down. We'll get your attendance fixed up right now.
Oh, wait, that's not, these are notes?
Yeah, these are the notes.
Yeah, hold on.
And they will be posted and all that good stuff. But this is what we're following. This is what we're working with here.
Don't change it, don't change it. This is nothing for me.
Save change.
There we go.
So the next thing we're going to look at is another rotation. So we went 90 degrees. Would be a pain if we just kept going 90 degrees at a time, right? You could if you wanted. If I wanted to do a 180 rotation, if we could make a rule so easy for 90, we should be able to make an easy rule for 180, right? So you could do two 90-degree rotations and go 180, but instead of doing that, let's try and figure out if we can find that rule. So let's look here. Okay, so starting with S prime, that new point for S prime is, let's see, that's 5, comma, -3. Okay, X prime is at +4, +2. And U prime is at 2, 1. What does it look like happens here? Yeah, all the signs change, both X and Y. So for a 180-degree rotation, that ends up being -X, -Y for our rule. And as you guys elegantly put it, all the signs change. That's the easy way to summarize what's happening here. So all the signs change. Not too bad, right? Let's take a look again at this in action. We're looking at that same.
Wait, so you don't move them around when they all change? You just keep them the same?
No. We just keep them. We just keep them in the same spot and just change their sides. Yep. So example 2. This is the same picture we just saw rotated. Let's rotate it now a whole 180. So again, that will be -X, -Y. So all I do is change the signs. This is 4, 3, -4, -3. 5, 3, -5, -3. 5, 0, that's -5, 0. And 2, -2 is going to change to -2, 2. So all I do is flip around our sign. So we should see this flipped around. Almost looks like it goes to the other side and upside down. That 180 spin. So that would be -4, -3. That's down here. -5, 3 is over here. -5, 0 here. And I have -2, 2 over here. Yep, that looks like it's spun around 180, right? Not too bad. Any question on these two rules so far?
So, this is how you do this. I was kind of lost yesterday.
Well, this is for the rotations. For the
Is
translations,
that what the quiz was about?
no, the quiz was doing proofs. This is the next unit.
Oh, okay. This seemed more easy.
Yeah. So like yesterday's work, again, we're just like, if I look back from number 1 from yesterday quickly, okay, I'm going right 5 up 1. So I added 5 to all my X's, added 1 to all my Y's to get my new points.
Right.
Oh, okay, this one, I don't know. Okay, that was kind of already done. So now there's one last rotation. This is a 270-degree rotation. So this is going like almost all the way around. So that's like a 270-degree rotation right there. It could also be seen as a 90-degree rotation in a clockwise motion. But again, it would seem to be a pain if I did like a 180 and then a 90 to get all the way to 270. Why am I going to do 2 different ones? Or I could even do 93 times to get there. But again, that seems a little much. So let's try and establish a rule. So let's see. J, that new point J prime is at, let's see. That is -2, 1. B prime is now at -1, -4. And then K prime is now at -4, -2. Anything you guys notice with this pattern here? Yeah, but with the points, what sort of pattern do you notice? Okay, so the numbers are staying pretty solid. What about the order of the numbers? From our, they're similar. Well, also notice we flip them, right? So our X and Y flip. Do all our signs stay what they originally were after the flip? No. Are these values changing or these values changing? The new Y values are changing. So they were originally the X. So when I flip it, it's now going to become Y, -X. The new Y values will change their sign. So what we want to do here, very similar to 90, is we flip X and Y, then change the sign on the back number. So whatever ends up in the back after you flip, that's a sign that needs to change. So again, my rules for these are super consistent every single time. So I know for this, I'm doing a 270-degree rotation. That's Y, -X. So let's start doing that. Which should my new point for Y be based off this rule? Well, remember the one that ends up in the back is the one that gets the sign change. So it should be 3, -4. If it was a 90, you would have been right, but now we're doing 270. So now what about this one? You're welcome. My next point should be 3 comma negative 5. Then I should have 0 comma negative 5. And then this one will flip. Negative 2 ends up in the front. The positive 2 ends up in the back, but then I need to change that sign. So that's negative 2, negative 2. So again, now I have the point 3 comma negative 4. 3 comma negative 5. 0, negative 5. And negative 2, 2. Connect my points. And now this rotate around a full 270. Now, as an extension to this lesson, this is all our rotations. Why aren't we going to look at a 360-degree rotation? Why do I stop at 270? Why don't I go another 90 degrees to a whole 360? Why don't I need to? What happens when we rotate 360 degrees? We do a full rotation, we're back to the same point. So is there any point to a 360-degree rotation when it comes to your position? None. It doesn't matter. All you did was spin in place. Yeah, I spun in place, but all I did was return to where I was. Mathematically, that's not very interesting, right? If I'm doing something where I'm trying to animate and move stuff around, doing a 360 rotation can be interesting just to see it move. But if I'm plotting its starting and finishing position, 360 does nothing. So that's what we have for today. Just stop share, stop recording.